all the terms placed in the even places are together taken on the other side. In 1 plus x whole to the power n minus 1 into ddx of 1 plus x. This is used derivative of a function with respect to another function. Good morning, welcome to btosacademy. Welcome to my maths class. Today I am going to work out first few sums on binomial theorems. Actually this is not completed yet, that is why I will work out few more sums. First, in the first part, properties of binomial coefficients. In the expansion of a plus x whole to the power n, the coefficients of the expansion are nc0, nc1, nc2, nc3, ncr, ncr, ncn. Now we are going to establish the relation among these. We consider the special case. While we shall discuss the relationship among these, we omit n's. That means binomial coefficients are C0, C1, C2, Cn. Here we have omitted n. For a equal to 1, we have 1 plus x whole to the power n is equal to C0, C1x, C2x square plus C3x cube, Cn xn. C0 is nc0, that is equal to 1. Cn means ncn, that is also 1. Now this is identity. Putting x equal to 1, what we get on the left side, it will be 2 to the power n, and on the right side it will be as it is identity, we can put suitable value, of course real value, for x equal to 1. Thus putting x equal to 1, we get this one. I call it 2. Putting x equal to minus 1, then left hand side will be 0. 0 equal to C0 minus C1 plus C2 minus C3 . It will be minus 1 whole to the power n Cn. Now we take all terms placed in the odd. Those are of positive symbols. C0, C2, C4, etc. From 3, C0, C2, and all the terms placed in the even places are together taken on the other side. Thus we see sum of the coefficients placed in the odd places is equal to sum of the coefficients placed at the odd places. Now, if I take each v equal to p, then 2p equal to C0, C2, first of all this one C0 plus C2 plus C4 plus dot 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 plus C1 plus C3 plus C5, this. That means if we now arrange, then the sum of the coefficients will be equal to this one. That means this is equal to 2 to the power n. Therefore, p equal to 2 to the power n by 2 to the power n minus 1. Therefore, C0, C2, C4 is equal to C1, C3, C5, that is equal to 2 to the power n minus 1. Now I am going to work out few sums on binomial coefficients. First I take this sum. First this sum. First I follow the terms C1, C2, C3, Cn. In the original one, sum of all the coefficients means C0 plus C1 plus C2 plus C3 dot 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 plus Cn is equal to 2 to the power n, but we find here C naught is absent. Then how to solve this? Here I shall apply the concept of derivative. First I write that 1 plus x whole to the power n is equal to C naught C1 x plus C2 x square plus dot 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 Cn x to the power n. Now, if I differentiate this equality with respect to x, then on the left side what we get? N into 1 plus x whole to the power n minus 1 into ddx of 1 plus x. Already I have discussed while I have discussed limit and derivatives. Left hand side, then n into within brackets 1 plus x whole to the power n minus 1 into derivative of 1 plus x, that is 1. That means finally n into 1 plus x whole to the power n minus 1. And right hand terms will be, first one independent of x, therefore 0. This will be c1 into derivative of x, that means c1 plus 2c2 into derivative of x, that is 2c2x finally, and this one will give n cn into x to the power n minus 1. Now if we put x equal to 1, then we shall get right hand side from here. That means we are using derivative method. Though this can also be solved with the help of algebraic method, but it is quite easier. Applying derivative, we solve it. Okay. Now, one plus x whole to the power n is equal to c naught c1x c2x square plus dot 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 plus cn x to the power n. Differentiating both sides with respect to x, n 1 plus x whole to the power n minus 1 into ddx of 1 plus x. This is used derivative of a function with respect to another function, already discussed. That is equal to 0 plus c1 into 1 plus 2c2 x plus dot 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 n into cn into cn into x to the power n minus 1. Derivative of x to the power n is n into x to the power n minus 1. Now this is also, I simplify first and I take the right part on the left, that is c1 plus 2c2 into x plus 3c3 into x square plus dot 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 plus n into cn into x to the power n minus 1 3c3, yes, is equal to n into 1 plus x whole to the power n minus 1. Derivative of 1 plus x is ddx of 1 plus ddx of x. First part 0, second part 1. I suggest students you must mention this thing. As it is identity, we can put any value for the variable. The meaning of identity is that for any real value of the variable concerned, both sides, values of both sides will be equal. We have to use that concept. That is why we must mention that. Putting x equal to 1. Left hand side becomes C1 2 into C2 plus 3 into C3 plus dot 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 plus we see n into Cn. That is equal to x1, therefore n 1 plus 1 2 to the power n minus 1. That is n into 2 to the power n minus 1. The sum is solved. Then number 2. Now this can also be, we can put the value x equal to minus 1, then we shall get another form. I take that as corollary. Putting and call this identity number, say A. Putting x equal to minus 1 in A. What we get? On the left side, in place of x, minus 1. That means on simplification C1, it will be minus 2 into C2. Then this will be minus 1 whole square, that means positive 3 into C3 minus 4 into C4, like this, dot dot dot. Finally, that will be minus 1 whole to the power n minus 1 into n Cn. Right hand side will be, we are putting x equal to minus 1, therefore this will be 0. This is also sometimes required to prove. Proved. Actually, we have to use this identity to solve both the. That is why I considered these two together. Then next sum. Next sum, given this one, then we have to prove that. Here first I follow the terms. Left hand side C0, 2C1, 3C2, n plus 1, and right hand side n plus 2 into 2 to the power n minus 1. Now if we follow this expansion and follow the relation to be proved, we see C0 is present in both cases. All the coefficients are present. I am going to apply the concept of derivative, already I have mentioned in the earlier sum. Now to keep C0 intact, what to do? We have to multiply it by x first. If we differentiate both sides, then derivative of constant will be 0. That is, to keep C0, we have to multiply first by x. Then we differentiate. Cn x to the power n. Multiply both sides by x. I think students, learner have followed why I am going to multiply the equality relation by x. I write this part on the left, C0 x plus C2 x square plus C0, sorry, it is C1. Multiplying each by x, it becomes C0 x, C1 into x square plus C2 into x cube plus dot dot. Last term will be Cn x to the power n plus 1. And right side will be x into 1 plus x whole to the power n. Now we differentiate. Differentiating with respect to x. It will be C0 2 C1 into x 3 C2 into x square plus dot 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 plus n plus 1 x to the power n into Cn. We have used this formula. I write that dtx of x to the power n equal to n into x to the power n minus 1. Now this is product of two functions u into v form. That means x into ddx 1 plus x whole to the power n plus 1 plus x whole to the power n into dtx x. Then we simplify, it will be x into n 1 plus x whole to the power n minus 1 into derivative of 1 plus x which will be finally 1 plus derivative of x is with respect to x is 1 and thus 1 plus x whole to the power n. In x 1 plus x whole to the power n minus 1 and derivative of this, result of this will be 1 plus 1 plus x whole to the power n. Now to prove this, you see it is clear, very much clear now. We have to put x equal to 1. Putting x equal to 1, this becomes c naught plus 2 c1 3 c2 plus dot 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 plus n plus 1 into cn into this part becomes 1. Thus we have got the left part, and putting x equal to 1 on the right, we get n into 2 to the power n minus 1 plus 2 to the power n. Now 2 to the power n minus 1 is the common factor. Thus we get the right hand side n plus 2 into 2 to the power n minus 1. Hence the sum is solved. This is the first part. We can write this one as 3 1 and number 2. I first copy that. No, it is finished already. The sum is finished. No need of taking that. The sum is finished. Next sum. To prove c naught square plus c1 square plus c2 square plus dot 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 cn square equal to this one. Given this one, 1 plus x whole to the power now if I reverse 1x, that is x1, then we shall get therefore x plus 1 whole to the power n. Then first term will contain x to the power n, second term x to the power n minus 1 like this, and last term c naught x to the power n plus c1 x to the power n minus 1 plus c to the x to the power n minus 2 plus dot 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 plus c n. Actually we are replacing or reverse, writing in reverse order, keeping the coefficients same. If I call this as 1 and 2, now we multiply these two, 1 into 2. Left hand side will be x plus 1, 1 plus x both same. Therefore, left hand side will be 1 plus x whole to the power 2n. Now, we just write the expressions without multiplying. Now, to prove this, first we follow. If we multiply these first two terms, we get c naught square. Then, if we multiply these two, get c1 square, etc. Now, when we multiply this, then product will be c naught square into x to the power n. When we multiply these two, we get c1 square into x to the power n. That means we are considering coefficients of x to the power n, equating coefficients of x to the power n from both sides. You may not write this. Then what will be the coefficient of x to the power n in the expansion of 1 plus x whole to the power 2n? Let us first find that. Let tr plus 1 contain x to the power n. Two n's here, 1 to the power 2n minus r, that is 1 into x to the power r. Now, this term contains x to the power n as therefore x to the power n equal to x to the power r. Therefore, coefficient of x to the power n is equal to 2n cn Therefore, we are now equating to n Cn. Now, value of this is factorial 2n Therefore, final step is C0 square, C1 square, C2 square, Cn square is equal to factorial 2n divided by this is factorial n, this is also factorial n, that means Therefore, the sum is solved.